Okay, so good morning, all, and welcome back to the session. Friends, in previous weeks or in previous sessions, what we have seen, we have gone through with the advanced RAG optimization techniques. And from the optimization techniques perspective, what we have seen, uh, like inside the RAG optimization, there are two levels of optimization: retrieval level optimization and the generation level optimization. So the generation level optimization is quite simple and it is very easy to achieve. We just need to uh, add the source information. That can be the citation related stuff. Like if we are adding the resource source information of the data, like this particular information is being provided by this particular document, and user will be able to believe on the outcome which is given by the large language model. But that is not enough, and we need to have some optimization as well. So the next level of optimization is retrieval level optimization. Inside the retrieval level optimization, what we have seen, there are three main things: query transformation, query routing, and query indexing. So, from the query transformation perspective, what we have seen, these are different approaches that we have gone through: step back approach, and one more was there that is known as hide. Okay, so from the query transformation perspective, we have seen these particular things. These are nothing but the main motto over here is to transform the query, to convert the query in such a way that we will be able to get more and more information. We will be able to retrieve more and more information now. So that is given by query transformation. Once we are talking about the the rest of the techniques, say the routing, query routing, and over here what we have seen, like uh, route the query to to a particular database, to the required database, route the query to a particular prompt. And we have seen it as well. And we were able to see that once we are typing a particular query, and the large language model is going to check, like, is it related to this particular database, then it is going to route the query to that particular DB. So routing is quite easy. It was quite easy. And what are the different types?
Logical routing and semantic routing.
Semantic routing. Semantic routing. So logical routing is defined when, and inside the semantic, the large language model is going to decide semantic routing. So we have seen this particular stuff as well. We have gone through with this particular stuff as well. Now, query indexing. So query indexing is a little bit more advanced stuff that we are going to discuss on top of that. Now, so far what we have seen, like we are having some documents, and then we are going to perform the chunking. We are going to perform chunking, then embedding, then vector DB. Okay, then LLM, and finally we are able to get the outcome output. So this is the stuff what we have seen so far. Now what is being happening in indexing over here? once we are going to perform the chunking, okay, and then embedding is done, and inside the vector db the similarity search is happening onto these particular chunks, huh? Correct? Making sense? Am I right?
Yes. Yes.
Okay, okay. So we are going to perform the similarity search onto these particular chunks, and then some documents which are related to query, those will be passed to the large language model, and we are able to get the outcome. Okay, but just have a look over here. What is being happening onto the indexing? Indexing is of two types: multi-representation indexing and or multi-vector representation basically, and raptor, huh? So this is of two types, huh? Once we're talking about the indexing, it is of two types, huh? And indexing is like we are going to index the documents, huh? And how that indexing is being happening, that we are going to learn now. So what is being happening over here, so over here a step is added, one more step is added in order to perform this particular indexing. Once a particular query is coming, so once we are having the documents, then those particular documents are given to the large language model, and we are going to create the summaries on top of that. Just try to focus over here. Previously, we were having documents, and then we are going to perform the chunking, embedding, and then we are moving it to vector DB. But over here, inside the multi-representation indexing, the documents are there, and then documents are given to the large language model to create a summary, and the summary is embedded to the vector database. Over here, the summary is embedded to the vector DB, and once the user is asking a particular question, so that question is going to perform the similarity search inside the vector database, and that particular summary is being picked. And once we are having a particular summary, so summary is linked with the document as well, huh? So it will be having something like this. Say I'm having say 10 documents, huh? Doc 1 is there, uh, doc 2 is there. Let me take an example of with three documents only. So I'm going to have three documents, and with these particular documents, what I'm going to do, I'm going to create a summary 1, summary 2, summary 3. Okay, and I will be having a particular ID, like that will denote that this summary is belonging to this particular document. So say ID 1, that is summary 1, and ID 2, summary 2. We can take it in this particular way. Okay, ID 2, summary 2, and ID 3, summary 3. Okay, so this is denoting the document number. Like with respect to this particular document number, this is the summary. With respect to this particular document, this is the summary. Okay, so we are having the summaries of the documents what we are having, and we can have thousands of documents. So what we will do with the help of large language model, we are going to create the summaries on top of those particular documents. Now, what will be the next step? Once the user is going to ask a particular question, so it is going to retrieve what? It is going to retrieve the summary. Okay, so say so inside the multi representation index, what will happen? I will retrieve the summary instead of the chunks. what was there initially once we are going to perform the search, similarity search inside the vector DB at this moment, and we were getting the chunks from the vector DB. Okay, documents basically, say chunk one, chunk two, say we are having, let me take it in this particular way. Say we are having 200 chunks, and these chunks are embedded to vector DB. And now, once I'm going to perform the similarity search, then say I'm getting four chunks. Huh? These are nothing but say docs. Okay, I can say chunks, I can say docs. Huh? But this is what I'm getting after the similarity search. Now over here, once I have created the summary and I have moved it inside the vector DB along with the document number, document ID. So once a query is being asked, then it will perform the similarity search and I will be getting the summary from the vector DB. Okay. Now, what will happen? So, is this summary passed to the large language model? Is this summary passed to LLM to frame answer? You need to pay attention over here. That is no. Okay. Okay, so this summary, what we got after the similarity search, say we performed a search and we got the summary one, and this summary is not passed to the large language model to frame the answer. What will happen at this particular moment? Uh, we are having the relation between this summary and the documents, these particular documents. Say we are having these three documents at this moment. So these three documents are moved to the data store or doc store basically. So over here inside the doc store, it will be look like this. So this is a vector store, and inside the doc store I will be having this particular ID along with say doc1, doc2 and doc3. Okay, doc3. So the doc store is containing this particular information and the vector store is containing this particular information, that is containing the summary. Okay, now once a question is asked, then the similarity search will happen onto the doc store and it will fetch the fetch this particular piece. Say based upon the similarity search what I got, the id one and summary one. Now what it will do, it will search this particular id inside the doc store, say this id one, and then what will be given to the large language model, this doc one is given to the llm in order to draft the answer. Just look for a minute and ask if you are having any doubt onto this particular approach. All of you?
सर ये वेक्टर स्टोर और डॉक स्टोर का जो कंसेप्ट है सर ये क्लियर नहीं हुआ सर, एक बार और बताएंगे
Okay, okay.
किस तरीके से सर अलग अलग क्यों लिया है सर, तो कंफ्यूजन है इसमें.
Perfect. So what was happening initially? The initial approach was this one. We were chunking our documents and then moving the chunks to the large language model in order to frame the answer. Now, in order to improve the retrieval process, in order to improve the accuracy, what we are having the another approach, that is indexing, query indexing. Inside the query indexing, multi-representation indexing is there. And over here, what we are doing, instead of searching onto the chunks, so what is the limitation of, you can say, chunks? It might be possible, say we are having 100 chunks for this particular document. Just pay attention over here. 100 chunks of this particular document, doc1. But what we are taking only say 5 chunks. Okay, if we have set k equal to 5, then we will be fetching 5 chunks only from this particular document, correct? In the previous
Yes,
approach. So if we
yes,
are
yes,
fetching the 5 chunks only and remaining, say there are 20 chunks, so remaining 50, there are 20 chunks in total from the document 1, and we are taking 5 chunks only in order to draft the answer, then the outcome what will be generated, that will be the hallucinated one. It will not be the fully correct output. Correct?
yes.
Okay, so what we are doing at this moment, we are creating the summary of each and every document, and then move these particular summaries inside the vector store. Okay, now we are having the summaries inside the vector store. Okay, document summary, say we are having one document, two document, or whatever, 100 documents. So each and every document summary will be moved inside the vector store. Okay, now if a question is asked, so if say I'm having two documents, you can take it in this particular way. So one document is related to LangChain and another document is related to say Python programming. And my document, my question is what is LangChain? So the summary with respect to the LangChain will be stored. The summary will be say in the summary for the LangChain document will be stored in summary one, and for the Python it will be say summary two. Okay, so what it will do, it will take the summary one. Okay, so summary one has taken based upon the question, and that summary is, you can say, related to the document one, the LangChain one, and that particular document is given to the large language model in order to provide the relevant full doc, table or image given to the large language model to frame the answer. Correct? So the
So,
document.
sir,
Mhm, mhm.
in this way, we are increasing the accuracy of the document fetching, and as well as the resource, um, like a chunking optimization, is also is a part of this model. But but
Chunking is also done over here. Chunking is not done over here. Okay, we are not going to perform the chunking.
okay.
Mhm.
So we are using the large language models two times here. First to make the summary, and
Yes.
after vector store, we are when the question is prompt there. So the LLM again search the relevant document and mark the summary with that particular query.
No,
Is it?
first the large language model is going to create the summary. Okay, and
Yes.
then based upon these particular summaries will be moved to the vector DB. Now the similarity search will happen onto the vector DB, and we will be getting the ID. Okay, say over here we are getting say ID1 summary 1. Okay, so this ID1 is is available for the available inside the doc store as well. So I will be having the information that this summary is related to this particular document. So what I will do, based upon this particular ID, I will take the document and give it to the large language model to frame the answer. So first moment, at the first moment, the LLM is used once the summary is being prepared. At the second moment, it is used once it is need to provide the answer based upon the document.
Okay, sir.
Okay, so it is used
Yes.
two times.
So when we are using
So
chunking, but
Mhm.
sometimes what is happening, we are missing some part in the output. So that problem can be resolved here, right?
Yeah, that can be resolved over here, but it is having its own drawback as well, to be very frank. So the drawback is it might be possible the document size is uh, huge, which is given to the
Hmm.
large language model to get the answer, to frame the
Oh
answer.
yes,
Mhm.
the whole document
so
will be
in
given to
this
the one.
Yeah,
so in
Hmm.
this
And
method,
output tokens
we are
also increased.
Yes.
yeah, definitely.
Yeah, that increased the cost.
Hmm.
so in this method, chunking is like we are not doing chunking before embedding, or chunking is also there
No, no,
before
no,
embedding.
chunking is not done. I haven't done the chunking over
Ah,
here. This is the initial
okay. So
approach.
that's
Huh?
why.
Uh-huh.
Okay, so that's why instead of chunking, we are doing the indexing kind of stuff. Like
Uh,
somebody is related to indexing.
actually, once you are moving something inside the vector DB, that is nothing but the indexing. Okay.
Mhm.
If you are moving something inside the vector DB, that is indexing only. If you are embedding something, that is indexing only. So indexing can be done into the multiple ways. Indexing, multiple types of indexings are there. Okay, but in order to improve the retrieval process, what is the indexing? What is the type of indexing that we need to have? That is, uh, we can say of two type, raptor and multi-representation indexing. And multi-representation indexing is working in such a way like it will be working based upon the summary and the complete document. Correct?
Okay.
Clear with everyone?
Yeah, so here summarization will be done at a time, right? If we are asking multiple question, that is at starting only it will do the summarization, and then you can ask multiple questions.
Multiple questions, I didn't get it properly.
Like if you are having if you have given document related to finance, so you have given 5 document related to finance,
Hmm.
and it will do the summarization of all 5 document, and
uh,
summary will be given.
so
Then you can ask one question, second question, third question. So every time it will not going to do summarization, it will just do summary once, and it will store somewhere.
so multi-representation indexing, that is document by document. Okay, it is not related to a category of documents. The category of documents will be covered inside the Raptor, and that is the another approach. Okay, what you are trying to say, what I'm able to get, the Raptor is, say you are having finance document, you are having say HR document, you are having say R&D document, okay,
Hmm.
and finance one, you are having say. So what you are talking about, what I'm able to get, correct me if I'm wrong over here, based upon your query, what I'm able to get, say you are having different documents with respect to
Hmm.
the departments. Now,
Yes.
uh, we need to create a summary. Okay, say finance will have one summary. Is it correct?
Yes.
Okay, so this is the Raptor approach. Basically, it is not with respect to the multi-representation indexing. Over here inside the multi-representation indexing, we are going to create one summary for each document. one summary for each
Mm-hmm.
document. We are not going to categorize the documents inside the multi representation indexing. Okay.
Yeah,
So
so that summary will be stored somewhere, or it will generated every time we are going to ask
no,
a
no, no,
question.
no, 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 no. Vector store is something like which is having the which it is going to store those particular documents, document summary. Yeah. Even doc store is going to store the documents. We're talking about the RAG approach. It is not like we are going to push the documents each and every moment. Although we can do that,
Mm-hmm.
but uh, in our case, we are just asking the question based upon these particular documents. What we are having, and based upon these particular documents, what is the approach? Initially we are first creating the summaries and moving into the vector store, and the documents will be moved to the doc store. Once the question is asked, it will pick the summary and id. Based upon the summary and id, it will pick the id and the document, because id is the common between the doc store and vector store. So it is able to pick the document, and that document is given to the large language model.
Okay, got it. Thank you.
Okay,
Thanks.
so this is the case. Now, let's try to understand it with the help of practical. Then you will be having the better clarity. And okay, so I'm ready with this particular uh, notebook, and I have done some imports. And let me try to pick some part from our previous examples. I just want to take two documents in order to proceed with our example or practical. So these are, so I can take another one. Okay, let me take this one. So what I'm going to take, say, loader equal to this. So docs equal to loader dot loader. Okay, so what I'm doing over here, I'm loading the document one, and then I'm going to create a list basically of this particular document. So this is a document, and I'm going to load it as a list, and then in this particular list, I'm appending the another document. What has happened? List objects extends extend, that is nothing but extend. Okay. So, I have loaded the documents. So, with respect to our example, what we are trying to do. So, we will be having some documents, and say document one is there and document two is there. So this is the first document what we are having, and this is the second document what I'm having, and I have created a particular list, say doc one and doc two. So this is a particular list what I'm having. I have taken three documents. I can take thousands of documents, but with respect to this uh, practical, I have taken these two documents, and I will proceed with these particular documents. Now, what I will do, I need to create the summary based upon these two documents. Correct? So what I will do, I will define a chain over here. Chain that is, say, I haven't defined the large language model and all. Okay, I will do it later. So chain, and what I will do, this is equal to, and I can take it in this particular way, say doc colon, just try to understand. If I'm passing x, then x dot page content. Okay, so what is the meaning of this? What I'm doing over here, if I'm having a particular document, I'm loading the document, and with this particular document there will be metadata and other control information. So what I will do, I will just take the page content, because I just need to create the summary based upon the page content. So if I'm having X as a document, and I'm going to take the page content from that particular document, correct? Then what I will do, chat from template. Let me copy it from here. Chat from template, and dot from template, and I can define the template over here only. Yeah. Okay. What I can mention, summarize the following documents. Documents, and I can have the new line character, and then I can pass the doc. Okay, so this doc is passed over here. Now this is nothing but I have taken the page content inside the doc, and this doc I have given over here, uh, inside this particular template, in order to generate the summary. Yeah. I have given this particular prompt. Now what I can do, I can have the chat open. Yeah, I can have the large language model. Mm, Chat OpenAI. I can have chat OpenAI, and I can say temperature equal to say 0 and model equal to GPT 4 or say let me take mini GPT 4 or mini. Okay, this is the model I'm going to have, and then string output parser. Okay, are you able to get what I have done over here, all of you? Is it clear with everyone? So
Yes.
I have given the documents, then prompt is given, and then it is given to the large language model. And whatever I'm getting, I'm just creating it in a neat and clean view. Okay. So I have defined this particular chain, correct? Now, one more thing that you need to focus. What it will give? It will give summaries, correct? This chain will give what? It will give summaries, right? Say yes or no.
Right, right.
Okay. So chain. Now over here, as we are talking about the two documents, but we can have thousands of documents, and we can't, you can say, process all the thousands of documents in one go. So for the for the benefit perspective, what we are going to do, we are going to process these particular things in a batch, and I will mention the batch size. I will pass this particular docs, and I will have say max concurrency, max underscore concurrency colon say 5. Okay, let me take 5. So it will chain dot batch. Okay, so chain dot batch, and I will pass these particular documents, and max concurrency will be 5. Okay, so let me have the execution of this, and I will be having say summaries at this moment. So with respect to our notepad, what we have done so far, we were having some documents. Okay, so with the help of those particular documents, we are uh, creating the summaries. Say docs were there, then summaries, create summaries. Okay. Okay, so uh, summaries for these particular documents are created. Now, if we are having the summary, then what we need to do? We need to move the summaries inside the vector store, correct?
Correct. We need to move
Okay,
summary to vector store to
yes,
identify the documents.
yeah. So we need to move these summaries to the vector store. Now, what I can do, say vector store, and what I can do, say chroma, and collection name, and I will pass collection name equal to summaries, and then embedding function. Embedding. This is same like we are going to take OpenAI embeddings. Huh? We have done it. Huh? This is vector store.
Chroma spelling is wrong. CHROM.
Hmm. MB. Okay, so this is the vector store. It will take the summaries, and then inside the vector store, things are inside the embedding format only, and which you can utilize any uh, embedding model over here. So OpenAI embeddings are being utilized in order to perform this particular, you can say, embeddings. Now, one more thing over here. Then what I need to do, uh, I need to, I have defined the vector store. I haven't, so inside this particular vector store, we will be having the summaries. And what about this particular uh, doc store? So for doc store, what I'm going to do, I'm going to utilize in memory store. Okay, so I will be moving the documents inside the in memory store, and I will utilize the doc store and in memory doc store, in memory store, and the vector store in order to perform our operation. So store equal to in memory store, in memory byte store, sorry, byte store. This is the store what I will be going to use for the documents, and id key equal to the doc id. Okay, so these are the things what I'm going to use. ID key, this is nothing but this particular ID, okay, that will be used to identify the summary and the document. So what I will do, I'm having these particular things. Now I will define the retriever. And retriever, what it will be, uh, at this moment, what I will do, multi-vector retriever will be utilized. Multi-vector retriever, and then vector store equal to this vector store. Okay, and doc store equal to this store what I have defined. Okay, and id key equal to this id key what I have defined now. Okay, so this is the retriever what I'm having, that I have defined now. Okay, now what I will do, uh, so id key, sorry. So what I need to do, mm, hmm, so doc id equal to uh, so I will so UUID, a particular library that I have imported over here. UUID, that is nothing but unique identifier. So what it will do, it will add a unique identifier onto each and every document, onto each and every document, and onto each and every you can say summary. So I will be going to utilize a UUID library in order to generate this particular unique ID, what I can say. So doc ID is equal to uh, uh, UUID dot UUID 4, and it will be something. It is a list comprehension string UID, and for any doc in the docs summary doc equal to document page content will be of say s, and then metadata equal to id key colon doc IDs, doc IDs of I. So what I'm going to do, let me first have the execution of this and see. Uh,
Sir, what is this UUID4 function?
GUID is going to generate. Just have a look over here. This is a unique ID. What I have generated. Doc IDs. I have printed the doc IDs over here. So this is a unique identifier with respect to the summaries I'm going to generate, and the over here, if you are able to see, I just need to have a unique ID with respect to this particular summary. Yeah. I have created document 1 will be having summary 1, document 2 will be having summary 2, but I just based upon this particular summary, I just need to search the document. I need to fetch the document from the doc store. Okay, so do I need to perform a search over here based upon similarity and all? This is the normal doc store. This is in memory byte store. It is not having the capability like the vector store. Vector store is going to provide the searching based upon the similarity. It is checking the query and perform the similarity search and provide the summary. Say this query is related to this particular summary. Correct. Now, uh, with respect to the summary, I just need to fetch the doc as well. Okay, so summary is from vector store and document is from the doc store. We are having the different, you can say, DBs over here. So in memory byte store, that is the another doc store what I'm having, where I'm having all the documents. So based upon what I can search from the doc store, so based upon this particular ID, And this ID is generated with the help of UUID function or library. Basically, UUID is having UUID4 function, which is going to generate a unique ID based upon a particular summary. Okay, now this summary, this ID, based upon this particular ID, I can fetch the document from the in memory byte store, right? Are you able to
So
get?
this ID will be in both place, vector store
Yes,
as
yes.
well as the doc.
That's why I have mentioned it into both of the places. Huh? It will be
Yes, yes.
same. Huh? And based upon this
Okay.
idea, I'm going to fetch the document which is related to this particular summary. Huh? Summary one related to document one, but based upon what? Based upon this ID only. Huh? Correct. So over here, what I'm doing over here, I'm iterating. Just try to focus over here. Say I'm having two summaries. I'm iterating with the help of summaries, and I'm taking the doc IDs. Okay, from here. Okay, so I'm having docs based upon docs. And what is docs over here? So docs is nothing but this particular list. Huh? Okay, so I'm having two documents inside this particular list, and based upon these particular documents, it has generated two IDs, and these particular IDs are mapped with the summary documents as well. Huh? Is it fine with everyone? Let me repeat it once again.
Yes.
Okay, let me repeat it once again. So we are having documents, and documents is from where we are getting the documents. Once we read from these particular URL, so we are getting the docs, and this is nothing but a list. Let me try to print it as well. Huh? Say docs. So this is nothing but the content, complete content. Huh? And if I'm printing, say print type of this particular docs, it is nothing but a list. Huh? Okay, okay, this is the list. Now I have inserted the documents inside this particular list, and what I need to do, I just need to generate the the unique identifier for these particular docs. Okay, that is perfectly fine. So I have generated the document IDs, and with the help of this particular UUID4 function, the IDs has been generated. Just have a look. These are the unique IDs with respect to the documents what I'm having. If I'm having three documents, so there will be three IDs. Huh? Now, what I'm doing over here, I'm having my you can say uh, page content. Okay, I'm having the summaries. Okay, so the documents are having the unique ID. Now I just need to map this unique ID with these with the summary document summary as well. And just have a look. Let me try to print the summary document as well. So let me first print summary, then you will be able to get print summaries. So summaries are nothing but this one. Okay, uh, it is nothing but the content uh, that has been generated by the large language model, right? Correct. And let me try to, this is nothing, let me try to print the length of these summaries. Okay, how many summaries are there? Two summaries based upon two documents. Correct. Doc 1 is having summary 1, doc 2 is having summary 2. So I'm having two summaries basically. Correct. Clear so far?
Correct, correct.
Okay. Now what I'm doing over here with respect to the summary doc, just have a look over here in summary doc. Okay, so this is the summary doc, and this is nothing but document ID is mapped with the page content. This is this summary is related to this particular document, document ID, and this document ID from where we are getting. This is the document ID, yeah? Correct. E84CB91, and you will be able to see E84CB91. Correct. So over here, what is the motto of this particular line? I am having the document IDs. So these document IDs are mapped with the summaries, and I am having doc ID comma summary, and these particular summaries, this particular stuff can be utilized in order to fetch the documents from the doc store. Correct. Is it fine with everyone? This is simple stuff, like I am taking the documents, page content equal to s, metadata is nothing but id key, and doc id is what I'm having. So I will iterate with the help of this, and then for I comma s enumerate is summaries. So what is being happening over here, it will be look like this one. So it will be look like this one. Say I'm iterating it over here with the help of for loop. Okay, so I equal to 0. Okay, once I equal to 0, so s what it will be, s will be the zeroth document summary, and I, sorry, this is I, once I equal to 0, and once I equal to 1, then s what it will be, the first document summary, summary. Okay, so I and s, I equal to, say once I equal to 0, so it will be you can say first zeroth document summary, because it will be iterating, the indexing start with 0. Okay, and that's what we are able to get. So uh, over here, zeroth, you can say iteration, so it will take the first document summary, and then first index it will take the second document summary, yeah? Document ID and summary. Fine. Is it fine with everyone? Are you able to get are you able to understand?
Yes, yes.
Okay, perfect. So we are having, so hmm. So we are having, we are at this particular stage. So we are having some ID and summary one. Okay. And we are having ID and the docs as well. So we are fine. Now what I can do, I can set the retriever. Let me try to do. So retriever, uh, have I get to the retriever? Hmm. Retriever dot vector store dot add documents and say summary documents, summary doc. Docstore dot mset list and zip doc IDs comma docs. Okay, so summary doc, just try to have a look over here. Now this is the retriever, this is the retriever what I have set over here. Just have a look over here, retriever, so retriever is nothing but it is having vector store and it is having doc store and it is having IDs. Now what I'm doing over here, inside this particular retriever I'm adding the documents from the summary doc that I have created over here. Okay, this is the stuff what I have created. It is having summary and the doc ID. Inside this I'm having summary and doc ID, so I'm moving it inside the retriever. And the doc ID and docs I'm going to to move inside this particular retriever as well, so retriever, what I'm going to set, that will be having both of this particular information, right? From where I need to retrieve the documents with the help of multi-vector retriever. Now multi-vector retriever is having summaries, docs and docs IDs. Summary doc is having doc ID plus summary, and this doc ID and docs I'm giving to the docs, that is from the doc store it is given to the retriever, so retriever will be having the summaries, that is nothing but doc id comma summary, and this doc id plus comma documents, it will be there inside the retriever. Okay, and then this particular stuff I can utilize, incomplete output, what is what has happened, is it something like that? Okay, is it fine with everyone?
Yes, yes.
Okay, so I can have a query and say what is what is LangChain, and what I can do is sub doc, and I will use what vector store vector store dot similarity search, and query I will pass query and k equal to 1, and sub doc So let me try to have the implementation. What is the issue? Okay, so just have a look over here. What I have done now, the retriever is having retriever dot vector search. This particular retriever is having each and everything, and now what I have done, I am having this particular, you can say, query, and based upon this particular query I can perform the similarity search, and I will be able to get this particular stuff. And what I can do, I can have, say, retrieved documents, retrieved docs equal to retriever dot invoke dot invoke, and I can have query comma and results equal to 1, retrieve docs dot. Okay, so just have a look over here. What I have done, so retrieve docs, so I have like I have invoked the retriever with the help of query, and I'm just going to take, you can say, one document over here, and one document because I just want to have the one summary, and one summary. What is being happening over here? You need to pay attention. Now, now you are having retriever, and retriever is having your id comma doc and id comma summary. Okay, so these particular things are there inside the retriever. Now what you are going to do, you are going to invoke the retriever, you are going to invoke the retriever based upon a particular query. You have asked the query. Now if you have asked the query, then what you need to do, you just need to have the outcome with respect to, say, single document over here. So if you are going to take multiple documents, and then the answer is being prepared based upon the multiple documents, so that is a little bit, you can say, problematic stuff with respect to our use case. So what we have, probably you will not get this particular statement, what I'm trying to say over here. Now you can take it in this particular way. Over here we are having, say, finance. Let me take this particular stuff. We I have asked the question, okay, and I will get the outcome. So I'm having three document: finance, HR, and R&D. So if I'm going to take two documents or two summaries, and based upon two summaries, I will be having two documents. So finance and HR will not make any sense. If my question is with respect to finance, so the HR documents, if I'm going to take, then that will not make any sense. Is it correct?
Correct, correct.
Okay, so over here, what I'm trying to say, I'm going to take one result only. What is the meaning of this? So the based upon the query, it will take only one summary and one document. So one summary with respect to finance, summary, and say with respect to summary one, I'm having the doc one. Okay, if I'm going to take say two summary over here, definitely the the end results, if I'm going to set it to, it will take two documents, but selection of this particular summary 2, and then doc 1 and doc 2 will not make any sense, and I will not be able to get the correct outcome on top of that, correct. So I have, you can say, mention the single result only, and based upon that, I'm able to get the outcome as well. So this is nothing but multi-representation indexing. The approach is a little bit different over here, where we are going to first create the summaries based upon the documents, and then we move these particular summaries inside the vector search, vector db. Once a particular question is asked, then the search is happen inside the vector store, vector database, and over here we are having the id, document id, and the summaries inside the vector store. That id is common to the doc store where we have moved the actual documents. Now, based upon this particular document, the large language model is going to provide you the outcome. Correct? Fine. Is this approach good? Are you able to
Yes,
get
yes.
all of you? Is it perfectly fine?
Yeah, it's fine.
Okay. Now, the another approach, that is Raptor. This is a little bit more advanced. Okay, and I'm not going to like move with this particular approach practically, but I just want to show you what is being happening. So I think someone who I'm not able to get the name, who has asked this particular question, like if we are having the multiple documents into the same category, okay, uh, or different types of documents are there, then how to proceed. So a Raptor is an approach where like we are having multiple documents with same category, what I can say. And Raptor is recursive abstractive processing for tree tree organized retrieval for hierarchical indexing. So what is being happening over here? Say if we are having the different documents, so if we are having different documents, then what we will do, we will align the large language model to cluster those particular documents with respect to its category or with respect to its type. Say if we are having finance documents, so these particular finance documents will be clustered this into the same category. Then another cluster will be with respect to the HR, and say the another third cluster will be with respect to say R&D documents. Further, based upon these particular cluster, okay, the summary is being prepared. Say for the cluster one, this particular cluster, this is a HR or finance cluster. So the finance summary is there. With respect to HR, the HR summary is there. With respect to the R&D summary is there. Now we are having cluster summary, and this is you can say this is happening once we are having huge amount of data. We are having say lots of data. We are having lots of documents, and we need to uh, create a RAG chatbot based upon those particular documents. So so clusters are there based upon the cluster is summary is being prepared. Then what will happen? These particular things are you can say clustered. These particular things will be clubbed together and will create a cluster over here. And then we will be having the cluster level summary. That is nothing but the root summary, what I can say, which is having the crux of all of these particular documents. Now, if based upon the query, okay, based upon the query, the documents like where to route a particular user, that is decided by the category of the question. Okay, so if uh, if you can say the question is generic, let me, what will happen with respect to the generic one? Okay, so if the question is very, you can say specific, if like which is required the document level, you can say intervention. So it will be searched from here. Okay, if it is little bit, you can say generic, more specific, less generic. So over here, if the question is a little bit generic, then it is given to this particular cluster level summary. So these particular documents are being utilized. And if the question is you can say more generic, or lots of, you can say, general stuff is there, then it will be looked from this particular uh, root summary. Yeah? Okay, so based upon this more abstract or high level summary. Yeah? Okay, so high level summary is, you can say, the generic questions are being answered from this particular root summary. Specific questions or more specific questions in this particular way, these particular raw documents or cluster summaries or root summaries are being utilized in order to serve to the customer. Although like the code is given over here, if you want to have a try, you can go through with this particular piece of code. But uh, on to the organization level, even like I haven't implemented this in my organization, and this is a little bit more advanced stuff. And it is even like once we are going to have the implementation, we need to have huge amount of data. From the small amount of, you can say, data, we will not be able to get the benefit from the raptor approach. That's why like I haven't tried to have the implementation of this particular approach. So from the understanding perspective, you must be having the clarity like what is being happening over here. So the agenda is quite simple. Uh, the documents, all the documents are captured. Then these documents are clustered. Then the summary is being prepared with respect to each cluster. Cluster level summary is there, and then these particular summaries are clubbed together into the cluster, and then we will be having the complete summary of all the documents. So that is having the crux of all the documents. Now once a question is asked, so based upon the severity of the question, and the large language model is going to get the severity, and it will route to the respective, you can say, direction. It might be the root summary, it might be the cluster summary, or it might be the raw documents from where it need to get the answer for the user's query. So you must be having the understanding about the intent, like what is being happening over here inside the Raptor approach. So that is nothing but that's all from the indexing perspective what we are having inside the RAG chatbot. Hope it is clear with everyone. Is it?
Yes, sir. We will go through the recording again, sir.
Okay. So any doubts so far? Anything that you want to ask? Mhm.
No, sir.
Nikhil, Javed, Lakshmi, Yogendra, Manish, Vikas. Anything?
No, sir. As of now, no doubt. We will do some practice.
Okay. So
It's
you
fine
must.
for my side.
Okay. Okay. Perfect. So this is all from the indexing perspective, and uh, once like we are having these particular things in our hand, what we can say, we are good at the RAG optimization. This is perfectly fine.
Sir, please save the Jupyter notebook.
Mhm.
We didn't receive the last session also.
I have shared it. I have shared it. I have shared the notebook as well. I have shared the recording as well. Okay, no worry. If you haven't received, I will share it back. Mhm. Okay, so this is perfectly fine, guys. Now you all are having good understanding about the RAG chatbot, and believe me, inside the industry as well, nobody like few persons are there which who are having this level of understanding, like how the RAGs are optimized. Okay, now moving further, that is the most interesting topic. That will be the most interesting stuff, agentic AI. Okay. I'm just going to provide an overview, and from tomorrow onwards, we will be working on to the agentic one. Okay. So so far we have seen the the RAG chatbots, and RAG chatbots are having certain limitations. Uh, Once we're talking about limitations, uh, these are based upon the chains. What I can say chains. So lang chain is utilized in order to develop the RAG chatbots, and chains are nothing but a predefined workflow. Okay, predefined workflow. What is the meaning of this? Say if we are having this particular approach, document chunking, embedding, vector DB, LLM, and output. Okay, so uh, in each and every case, we will be having less or more same kind of stuff will be there inside the RAG chatbots. Okay, we are going to create the chains over here, and the chains are created say with the help of LangChain, which is nothing but a framework, and we are having a controlled flow over here. Controlled flow. What is the meaning of that? Uh, these are, you can say, these are having less autonomy. Okay, these are having less. You can say these are less autonomous, and if less autonomous are there, it means they are having the more reliability. RAG chatbots are reliable, to be very frank. Okay, reliable in terms of what we are having predefined workflows and all, but somehow we are limiting the intelligence of large language model, limiting the functionality of large language models. Large language models can do a lot of stuff, but just by limiting this particular workflow, we are limiting the functionality, limiting what we can get from the large language models. Okay, so uh, what we are having agentic AI, that is, you can say, the booming stuff inside the market, as well, and more, like, lots of persons are talking about the agents. Huh? Okay, agentic AI. So what is being happening over here? We are going to provide control to the large language models to perform a particular task. Okay, inside the agentic AI, we are going to provide controls to the large language models, and it can be it can be uh, given with multiple ways. Let me try to open Paint. So over here, so with the help of this particular diagram, what we are able to see, uh, let me have a particular star. Okay, star and mhm. Okay, so you can take it in this particular way. Say this is step one, and we are having the large language model over here, LLM, and this is step two, and this is step three. Okay, step three. Now, this is, you can say, over here we are not going to give, at this moment we are not giving the full control to the large language model, and uh, autonomy, or you can say a full control or level of control, that is that we are going to decide over here, like how much control I am going to give to the large language model. And there is another approach as well. Mm, you need to pay attention over here. Now, what I'm trying to say with the help of this particular diagram, these are the two diagrams, okay, and these are denoting the level of controls what I can give to the large language model. Now, say this is the diagram one, and this is diagram two. Uh, Over here, the level of control, what I'm going to give to the large language model, this is based upon, say, some conditions. Based upon some condition, I'm aligning the large language model. Either you need to take step two or step three. I'm having step one. I have taken step one, but based upon certain conditions, insisting the large language model either to take step two or step three. So over here, this is not fully autonomous system. It is not the fully although this is the agentic system, but this is not fully autonomous. So agentic systems can be of two types, where like we can have full autonomous and partial autonomous. Huh? So this particular example is denoting, this particular figure is denoting that this system, what we are able to see, this is not fully autonomous. It is partially autonomous. Huh? Wherever this particular example or figure diagram is going to provide me the view of a fully autonomous system. I'm giving the input and I'm getting the output. What are the steps the LLM need to take? It is decided by the large language model. There is no human intervention. Okay, so uh, that is perfectly fine, like partial autonomous and full autonomous. But what is the impact onto the functionality once we are talking about uh, the impact of this autonomous, of these particular autonomous system? Let me try to have another diagram. Okay, so over here, uh, okay, so in this particular diagram, what I'm having, say, hi, this is a reliability. Yeah, this is reliability low, and this one is say high, and this is low. Okay, and what I can say, this one is a agent control now. Okay, LLM control, whatever you want to say. So once I'm saying, we try to understand the behavior of uh, partial autonomous and fully autonomous based upon this particular diagram. What can be the impact? Now, once I'm having uh, the fully autonomous system, or once the agent is having full control, then what will happen? And once the agent is having less control, then what will happen? So the reliability with respect to the autonomous system, the graph will be look like this one. So say if we are having high low control is given to the large language model, then the reliability is high. And if high control is given to the large language model and or agent, then the reliability will be decreasing. So this is what we have seen inside the rags. Rags are not having inside the rag, we haven't given the full control to the large language model. So at that moment, reliability is high. But once we are talking about the agentic system and we are going to provide the full control to the large language model, so based upon the level of, you can say, control given to the large language model, the reliability will keep on decreasing. Okay, correct? Are you able to understand this particular piece and this particular piece? Are you able to understand? Reliability will decrease based upon the agent control. If the control is high, the reliability will be less. If the control is less, the reliability will be more. We will be having more reliable systems. Correct?
Yes, yes.
Is it fine with everyone? Are you able to get this diagram?
So basically, for which approach we use, we less low one or high one?
The approach and all that will discuss. Take care. No need to worry.
Okay.
Just try to understand the agentic and agentic behavior, basically what is being happening, how to have the control, you can say. Or let me explain that one as well. Okay.
Or is there any is there any
Okay.
in between low and high also?
So we need to keep the reliability as well. And so if we need to keep the reliability, we need to have the human intervention somewhere, right? We can't leave each and everything to the large language model. So what we can do, we can have human in loop kind of stuff that can add reliability along with the autonomous system. Okay, so we can add certain level of uh, level inside the autonomous mechanism, and or we can add some control. It is not like say we will be going to provide the complete control to the large language model uh, in order to perform the task. So we can have some human in loop kind of things in order to have that reliability. Now there is one concept, okay, and that this one is important as well. Uh, hmm. Okay, so okay, and what I can say, this one is okay. So over here, we are having a framework called as LangGraph. Okay, that is given by the LangChain itself, and uh, what we can do, we can increase the reliability of the agentic systems by adding more control towards the agents along with the reliability. Okay, so over here, if like we are having agents in order to perform a task, and if we are going to create the agents with the help of say line graph, which is a framework basically, so we are having the capability to increase the reliability, and we are going to add some mechanism like human in loop kind of things, where uh, we are not keeping each and everything onto the agent side, but we can have certain mechanism. With the help of that, we will be able to control onto the reliability. We will be having, we are able to increase the reliability a little bit more with the help of line graph. So uh, from the next session onwards, we will be going to have the discussion onto this particular line graph, in this onto this particular piece. Okay, so this particular line graph is a very rich framework. Although like different frameworks are there inside the market, with the help of that you can have the agent creation and all, but landgraph is most famous, and we will be going to see how to control, uh, how to provide less control or more control onto to the agents with the high reliability and all. These particular things we'll see. Correct, Javed? Is it making sense?
Yes, yes.
Okay, so we can increase the reliability along with the control given to the large language model. Okay, so I think that's all for this particular session. I just want to provide you some overview, like what we are going to cover, and uh, that's what I have explained. And from tomorrow onwards, we will be working on to the agentic systems, how to create agents and all. That will be more
Yes,
interesting than RAG. Huh?
this is a hot topic. Some people are starting from agentic AI
No, no.
and leaving the fundamentals.
And believe me, whatever I have explained with respect to RAGA, in your organization, just try to ask like how you have optimized RAGA. Um,
Yes, I
Very.
saw one job at my portal
Mhm.
about the optimization techniques, COT, and this height.
Okay, okay.
सर्कल मैंने भी आपको सर कुछ कुछ सैंपल मैं देख रहा था कुछ सैंपल ये जॉब्स का आपको उत्तर पर भेजा था उस टाइप की जॉब हम लोग भी अप्लाई कर सकते हैं
हाँ, I will talk to you separately, Nikhil.
ओके सर
Mhm. Okay, guys, then thank you. Thanks for joining.